Foreman, math interventionist here at Central. I was going to go over the rules of using exponents with you guys, since I know some of you have a quiz coming up, and a lot of stuff can be tricky to kind of get. So if you want to follow along with this PDF of this, you can do that. Otherwise, if you just want to kind of get a little brushing up of some of the rules of exponents, you can just watch this and then let me know if you have other questions. Okay. So first of all, adding and subtracting monomials. So monomials are, in this case, we see x squared y or w. So these are these terms that may have a variable in them. So as long as they're that same term, you are free to add and subtract those. So you guys have been kind of doing this for a while in algebra, where you have one x, you add another x, you get two x's. It's the same idea here, where you have, in this case, we have 9x squared y's, and you take away 10 of those x squared y's, right? So think of that x squared y as kind of a thing. You have 9 of them, and then you take away 10 of them, right? We see it's the same thing of that x squared y. So you have 9 of them, you take away 10 of them, it's just 9 take away 10, 9 minus 10. So with that, we're going to end up with -1 x squared y, right? Or you can just leave out that 1, because we know if there's no number there, that really means 1. So we can just say negative x squared y. All right. Great. So if we were to subtract 6w from 8w, simple enough. It's just saying 8w minus 6w. So 8w minus 6w, and you're just going to end up with 8 minus 6 being 2. So we have 2w. Simple enough. Okay, so that shouldn't be too new, but that is something we'll have to remember as we go through these. Great. So next we have the product rule. So what the product rule means is that when you're multiplying two numbers that have that same base, in this case, with our first example, we have a base of x. We have the same base of x. All we have to do with our exponents is add those two exponents together. So we'll keep that x, and then we'll just add our a and b. So x to the a times x to the b is going to be x to the a plus b. Simple enough. Okay. If we have h squared times h to the 6, same thing as the x's. We're just combining our exponents together, just adding those together. So h to the 6 plus times h squared, we're going to get h to the 6 plus 2, which is, of course, going to be h to the 8th. Okay. Now we get a little more complicated here with this example, because we're dealing with the coefficients, right? Coefficients are the numbers outside of those variables or outside of those monomials. So in this case, we have this -2 here, and that's 7. So we have to use our old rules we've always done for multiplying integers together. So we'll have to do that, and then we're going to use our product rule of exponents that's listed here. All right. So we have -2a squared b times the quantity of 7a cubed b. All right. So let's start going left to right here. So -2 times 7, same rule as always. -2 times 7, a positive times negative will give us a negative. 2 times 7 is 14. Now we have a squared times a cubed, right? Using our rule, 2 plus 3, it's just going to be a to the 5th. And then we have b and b. And of course, if there's no number there, right, we know that, of course, that means 1, right? So it's b to the first power and b to the first power. So 1 plus 1, we have b squared. Great. That's our product rule. Power rule. So if that's our product rule, our power rule as such. Great. So in this case, we have x to the a all to the quantity of the b power, right? X to the a to the b power. Okay. So that means everything inside there is going to be gone to the b power. So it's not going to be the same thing as this. So don't get confused there. Don't try to add these together, because we see how it's different. So x to the a all to the b is just going to be x to the a times b. So we'll say that as ab. So that's our power rule. We're just going to multiply those two exponents together. A and b multiplied together becomes ab. All right. So if we have x squared to the third power, let me show how this looks with a number. We're going to do that same rule. We're just going to be multiplying our two exponents together. But let me show you what it looks like for a second. So really this is like saying x squared to the third power. So x squared times x squared times x squared, right? There's 3 sets of x squared. That's what that cubed really meant, right? So if we go back to our power rule a second, that's x to the squared plus 2 plus 2. We're going to get 6. Or we just use our power rule. That'd be the easier way. 2 times 3, we're going to get x to the 6th power. All right, just the a times the b. All right, great. This one we kind of combine a couple rules in this one as well. So we have negative 2m to the 5th power, all to the 2nd power, and then times m to the 3rd. So let's first deal with this term here, and that in our parentheses, and then we'll move on to that m to the 3rd power. So if we have negative 2 m to the 5th all squared, that means everything inside that parentheses needs to be squared. So if we have negative 2 squared, that's negative 2 times negative 2, which of course would be a positive 4. M to the 5th squared, we'll use our power rule again, AB, so that's 2 times 5. So we have m to the 10th. And then we still don't forget about our m third here, so I'll just say times m to the 3rd. Great. So we used our power rule. Now we're left to use our product rule. Since we got m to the 10th and m to the 3rd, they're being multiplied together with that same base. We're just going to add the 10 and 3 together. Okay, so it ends up being 4m to the 13th. Great. Moving on, we have the quotient rule. So quotient, of course, means division. So as you've probably guessed, hopefully guessed, if we are dividing, we're gonna be doing the opposite of what we did for the product rule. Since division is the opposite of multiplication, what we're gonna do with our exponents is gonna be the opposite of what we did here. So since we have x to the a all over x to the b, we're just gonna be, instead of adding, we'll be subtracting. So we have x to the a minus b. Okay. So x over a, x to the a over x to the b is x to the a minus b. So let's put that in action. So number 1 here, let's work on just the x's for a second. And we'll leave our 27 over 42 for a minute. So if we have, this means, of course, x to the 1st, and we have x to the 5th there. So we have x to the 5 minus 1, right? So let's say 27 x to the 5 minus 1, which is, of course, going to be 4. And then we still have that 42 there on the bottom. Don't move him up. Okay. We should next try to simplify this really quick here. So we see each of these are divisible by 3. 27 is divisible by 3, so we can pull out that factor of 3, and that becomes, right, divide by 3 becomes 9, divide by 3 becomes 14. So now we have 9/14, and you could really say all that like so, 9 times x to the 4th all over 14, or you could say 9/14 times this quantity of x to the 14th. Sorry, x to the 4th. Right. So that's another way to say it, but it really means the same thing. Okay. Great. Next one here. So we'll have to first use our power rule to see that y squared all squared really means we have to multiply these two numbers there. So y squared all squared, we're going to get y to the 2 times 2, which is going to be y to the 4th, all over y to the 4th. Okay. We can use the quotient rule to go y to the 4th minus y to the 4 minus 4. So we have 4 minus 4, which of course is 0. And we should know, something we'll cover in a second, anything to the 0 power is always going to equal 1. So there we have it. That's our quotient rule. Okay, subtract those two exponents. When we have a quotient, when you have a product, we're going to add them. Okay, now we're at negative exponents. This is a little bit one of the more recent ones you've covered. So the negative exponent rule is whenever you have that negative exponent, that really means you're just going to flip our term to a denominator, so kind of do the inverse reciprocal of that. So instead of x to the negative a, if we want to make that positive, we would say that'd be 1 over x to the a. Okay. So the negative exponent means you just do that reciprocal, and then it becomes positive. All right. Here's a good example here. We have negative 5x to the negative square. So in this case, notice our negative 5. Does it have a negative 2 on it or any negative exponent? Nope. So that one's not going to be flipping, right? That one's not going to be the inverse. But our x with the negative 2 on it is going to be. So we'll leave our 5 on the top, and then that x becomes our denominator there, that x squared. So now we've made it positive by using that negative exponent rule. Okay, and simple enough, there we have it. You know, sometimes we often write it like this as well. It means the same thing. You put the negative outside the fraction bar. That doesn't matter which way you write it. Okay, great. We have here 4k squared over 8k to the 5th. So let's first deal with our exponents, and then we'll deal with those numbers. So we have k squared and k to the 5th, since they are dividing using our division rule, quotient rule right there. We're going to subtract those numbers. So we'll say 4k squared minus 5, or 2 minus 5. So we're going to end up 4k to the negative 3rd. And that 8 was still hanging out down there. Okay. Great. Now we'll stay focused on our term here a second. So k to the negative 3, of course, to make that positive, we could just put that in the bottom. 4 over 8k to the 3rd. It's now a positive exponent. Lastly, since we have 4/8, we know they have a common factor of 4. If you divide each by 4, 4 divided by 4 is 1. 8 divided by 4 is 2. So there we have our final answer there. 1 over 2k cubed. All right. Simple enough. Negative exponent. All right, last one here is the 0 exponent rule. So super simple. Anything to the 0 power is, as we already mentioned before, up there, it's always going to be 1. So x to the 0 is going to be 1. So for this case here, we have 7 times x to the 0 power. So let's focus on the variable a second. X to the 0 power means, of course, 1. So we have 7 times 1. And of course, we know 7 times 1 is 7. Easy peasy. Here we have a couple rules in play. We'll start with our power rule, XAB. So we have 4 y to the 4th. Sorry, y. I said that already once today. W to the 4th, all squared. So we got 4th power and squared. And that's going to be, according to our power rule, we multiply them together. So it becomes w to the 8th over w to the 8th. Now we will use our quotient rule. Subtract these numbers for division. 8 minus 8 is 0. Great, and now we can really use that 0 exponent rule. W to the 0 power is, of course, just 1. There you have it. Okay, so I hope this is helpful for you guys. You know, if you have more questions, you can always let me know, and that's all we have. All right, have a great day. Thanks.